Welcome back to the course Introduction to Commercial Banking and Fintech. In the last session, we discussed about the Basel II norms and also some of the important concepts that I thought we should be revisiting. In this particular session, we are going to focus on mostly on the internal rating based approach and especially on calculation of the probability default. So here, if I have to calculate the expected loss of a bank, then we go by multiplying probability default by loss given default and exposure at default, and this is what it is, the important concept related with that. So expected loss basically measures the risk measurement to pricing and provisioning, right, exposure at default. So these concepts are important. Let's move on and then we can focus on how do you calculate the probability default. So the basic understanding about the definition of the PD is that it basically measures that how a borrower defaults over a horizon, basically typically a year. So what happens that, as I mentioned, that in Basel II the risk weight were based on the credit quality. So this gave rise to a whole lot of data analysis and internal rating based approach. Probability default calculation became one of the important aspects of analytics. So here we are saying that y is equal to 1 conditional on x. X are the number of parameters. So x could be your the KYC details and firm specific details or any kind of characteristics that we have, and y is equal to 1. So we are assuming that y is equal to 1, it defaults. So normally in linear regression what we write is that alpha 0 plus beta xt, if I have a yt plus epsilon t, right, and this is what we have. But here y we consider that as a fixed number. So maybe if it is like, think about the SBI stock prices, and xt could be a matrix of whole lot of the variables that we can consider. If you are going by only one, so it will be vector, but if you are going by like combining all into 4 to 5, so then you can think about matrix. But if it is like one only variable, like if you am considering NSC, right, then we can go for incorporating. What is the easiest part is that when we have the dependent variable into a fixed number, then it becomes easier to estimate. But if the dependent variable is binary outcome, right, if dependent is the binary outcome, right, 0 1, then OLS becomes somewhat. So we estimate this model through OLS, and this t is not required here. Those who are learning for the first time regression, t is not required here. You can also write here y is equal to alpha 0 plus beta xi plus ui, right. So this is also a possibility, and I can go up to, suppose if I am having a number of banks, right, so I can go up to n. But I am saying that in the case when the dependent variable is binary outcome, OLS assumptions will be violated. Second part is that once we have the binary outcome and we are saying that if borrower default, it means that there is some kind of randomness or likelihood involved, and once the likelihood is involved, then if I want to calculate that likelihood, right, then I have to make sure that the probability that we are going to calculate, it remains within bound. And what is the bound for the probability? The bound for the probability is 0 1, right. So this is the bound that here we get. So what is the learning? That when the dependent variable is 1 0, and then when we are augmenting that with lot of other explanatory variables, then we have to go for some kind of classification models, and this is where the art of the data analysis of the banking data starts. Majority of the time we find that they work on the logistic regression setup, and under logistic regression setup, what is the idea behind that? You try to work on the distribution of the data. So normally it is having not the linear setup that we get, it becomes somewhat non-linear, and this is where the difference arises. And just to give you a brief idea, we will not be getting into so much details, but we create the odd that what is the proportion of defaulter with per no defaulter. So if I am having PD, say PD is 0.20, and then you have denominator 0.80, then it means that 1 defaults out of 4 no defaults, right. So that's what we often calculate. Second thing is that in order to make sure that the probability remain explainable or interpretable, and this is where it is very very important to find out, right. So this is what we get. Now here we have set up for your understanding one simple thing. Those who are not having the math and stats background, you may skip this section for a while and maybe focus on the generation that we will be discussing about PD. But this is estimation procedure that we do, that we have the, since I have to get into the probabilities and it has to be positive every time. So this is what we go for 1 upon 1 plus exponential, and this gi that we have, it is based on the distribution that we get into this whole expression, right. So these are the explanatory variables that we are getting added. Now coming back to the PD with default or no default data, so then we can get into. So let me just focus on the odds that here we have. So odds of default is, we have odds PD upon 1 minus PD. So PD is how much? It is 10%, suppose, then your odds are going to be 0.11, which means that one default every 9 non-defaulters, right. So this is what we have, which is like very good, right. And similarly a log of odd model that we get, so this also helps you calculate and the only part is that it makes you the smoothness in the data, that's what we use the log, and it also creates a good, somewhere it is also linked with the positivity kind of scenarios. Now the coefficient interpretation, if I have, for example, I have just taken up this particular question, which is beta j is equal to 0.20. So exponential 0.20, so 2.78 that we have the value, 2.71 that we have the value that we can multiply and get 1.22, which means that odds that we get, it multiplied by, so if it is beyond 1 it will be 22, and 1 minus that amount comes out to be the on the lower side that we get. So odd is multiplied by 22%, so this is what here we have. And nonlinear effect of PD, so change in PD depends on the how we calculate the PD, so it depends upon what is the value of the PD that we have. Then we also calculate the marginal effect. I think this requires some more elaboration, so maybe you can have a look at how we can calculate marginal effect when we have the logit kind of setup or probit or even logistic setup, and this will have almost, so it also brings the values closer to 0 and 1, and this is where we treat this particular analysis. Now coming to the coefficient explanation, so this is what we have written. I think I discussed this already, so let's move on. Now suppose if I have estimated the logit model, and this is how the model looks like, that the alpha coefficient is 3.2 plus here we have the unknown, first unknown coefficient is 0.04. I have the variable like debt to income, and then I have the credit score, and this is after estimation. We are seeing that credit score is having negative impact, right. So here we can see that once we have debt to income 0.04, which is greater than 0, which means that it is debt to income increases log odds of default, because this is what we have log PD upon 1 minus PD. And if you want to calculate that, it means that how much it is increasing, it is increasing by 4%. This is what we explain. Now if you think about the credit score, it is minus 0.03, so it is coming out to be how much? It is 9.97, right. So 100 point increase, it leads to how much? It is coming out to be 0.74 that we are finding, and this is what we call it as the, how it reduces the log odd. So it reduces the log odd by 0.74, and this is what it implies here. Now if I have to go into the, suppose I get this data from their KYC, right, credit score I get through CBIL. Suppose CBIL in India gives the credit score, so I get the data from there. I get this data from debt to income from their KYC declaration. What comes out to be 3.56. So log odd of default is going to be how much? It is going to be 3.56. But what is the meaning of this 3.56? So 3.56 implies that once we have 3.56 coming. So this is what it implies here. Then here we have, since I am converting that z into 3.5, and once I put that into this particular setup 1 upon 1 plus e power g, then it comes out to be 2.76 that we get, 0.0276. It can be converted in percentage. So it comes out to be 2.76. So probability default is just 2.76%, which is like much lower. But this, if it is on a higher side, then you can say that it will be a riskier part. But here we can think about what kind of portfolio we are considering. But in most of the practical situations, this is how it dealt with. I have also created a scenario that what will be the range of PD. So banks convert PD into decision using threshold and risk grades. So y hat is equal to 1 if PD is greater than C. So suppose threshold that is must be around 3%, right? So it should not go above that, it should be below. So if I am going to see that, then it means that 2.76 is less than 3%. It means that the borrower will not be flagged, and he will not be the high risk rule will not be applicable, because 2.76 we got the probability value and the threshold is 3%. If it is more than 3%, then the bank will put into monitoring. They will be also seeing their transaction pattern, where the household is spending money, whatever income that the household is getting, how much, where it is going. So those monitoring, you can say passive monitoring will start. Typical practice that we often see, that if PD is less than 1%, this is the best. But grade B will be if PD is probability default PD is between 1 to 3%, grade C is between 3 to 7%, and grade D is for 7%. So what it implies that banks also have their internal rating. So let me just give you a quick recap what we tried to get here. So here you can see that based on the sign of these, when I ran the regression, right, I got this result, and then Z I want to calculate first, and then I will be putting into odd ratio. So you can see that when we are converting into the odd multiplier that here we have, it is coming out to 1.04. It means that 4% increase, and here you can see that it is negative 0.97 that we are getting. So then this leads to only, you can say, if 100 point increase is there, then this leads to only 0.74 chances of log odds, right. Now once I have this particular setup, then we can also go for building up the model that we look at, and this also is very useful. So here we have a DTI is equal to 45, and then here the credit score is equal to 720. So log odds that we get here is the 3.56 that we calculate. Suppose I get a particular, in a year or in a month I get 45, and then here we have 720, so we get around minus 3.56. So interpretation is the log odds of default. This is what we imply, right. Now convert score to probability will be like probability default is 1 upon 1 plus e minus g, and PD is nothing but 1 upon 1 plus e power what is the value we got, 3.56. What we imply here, since minus it is here and minus plus, so it becomes plus here, right, because minus already is here and a minus already here. So we get the probability value 2.76. What is the meaning of 2.76? So banks are having certain thresholds of categorizing the customer. So this is what. So 2.76, if the bank has the threshold of 5%, then 2.76 is more than enough. If the bank has the threshold of more than 5%, then it will have a lot of trouble. Then the bank will be putting into categorization. And this is for your reference in practical life. I talked to some people, they also highlighted that this is what is the rule of thumb they follow for monitoring of the internal credit rating. Now suppose we develop, if we are told to develop or estimate a PD or develop a PD model for the Indian bank. So suppose a large Indian bank retail portfolio estimates a one year PD using logistic regression. So log PDI upon 1 minus PDI is equal to nothing but beta 0. Then here we have beta 1 DTI plus beta 2. Here we have the credit score. Beta 3 we have the self-employed, and beta 4 is the delinquency that here we have. And suppose for example we after estimation we get these values. So beta 0 estimated here, then here we have a beta 1, and here we have beta 2, and here we have beta 3, beta 4, and so on. So we can see if we have been told to calculate the PD, that how we will be calculating, then we will be going by the same exercise. First we will have to get the Z value, and debt to income ratio we calculate, that how much is the income and how much is the proportion. So normally in India more than 40% or 50% income cannot go as an EMI obligation, right. So this is what we imply, and based on these CIBIL scores and all, if we are able to find, so DTI we get, then credit score which is based on 300 to 9 scale, CIBIL score we say. Higher score implies that better credit rating, and it also implies lower probability default. Self-employed 10 that we get from the, so we are getting this data, suppose KYC form that customer has filled, and from there we are finding one borrower had 30 plus due date for due in past year, which means that due per calendar day that we say, so it is in past year. So and if the borrower had like 30 plus more than 1 month of due on debt, then this will be due past date it is called. So DPD is nothing but due past date. So DPD what implies that if the suppose the EMI was supposed to be paid on 5th of every month, but we find that the EMI has not been paid on the 5th and it is outstanding for more than a month, right. So due past date is 1 year, one time frame. After that we know that in the banking accounting you have SMA 0, SMA 1, SMA 2, and also the NPA is declared. So delinquency of 30 is considered as the strong case for default, right. So this we get into. Now the idea behind this is that how do we calculate the PD? Suppose we have these numbers given, right. So we put these numbers anywhere, this is going to be 0. So what we get is the Z value is minus 4.93, and if we calculate the, so 4.93 is the Z value that we are getting, and this is the example that we get, but we can go by the same procedure that we have done. So 4.93, and then we can go for calculating in the same way, that we will be putting the value 4.93 and we will be getting the PD value, and then we can categorize that which one is having higher or lower, right. So this is what we get here in this case. Now suppose we have another measure which has only two variables, debt ratio and the interest rate. So here we can see the G value that we are computing is 1.92, and if I go by the calculation of 1.92, so if I calculate the odds of this, so then we have 1 plus E minus G, so E minus G becomes minus minus plus. What comes out is that probability default is 12.8%, which means that this is very high, means that about 13 out of 100 similar borrowers are expected to default over 1 year period, and this is quite a stark number, and this particular cohort of borrowers will be put into monitoring, and they will be monitored on a daily basis or monthly basis, and bank will put some people on monitoring it, or maybe they will be developing some technology to monitor, right. So this is what you have. The another aspect that we often deal with this is the KYC data that we have. So KYC data in terms of risk variable. So we know that in KYC what all details we have. Here we have income, employment type, age, existing liabilities, repayment history, credit bureau score, then here we have a sector, industry classification, all these things are there. So when we construct variables, So x is equal to x1 up to xk, and x1 is the debt to income, x2 is the credit score, x3 is the self employed dummy. So if I have to estimate PD using logit, or if you are going for machine learning method, you can also apply, but these are the input that that is going, which was not there in case of Basel 1, right. Basel 1 it was not there. Now we are going for in Basel 2, you can see that all these things started coming, and macro management of the loan account started happening with this, right. So here you can see we got the, suppose we estimate with the KYC variables. So G that here we have, it is coming out to be minus 4, and debt to income is 0.03, monthly income is minus 0.02, and here we have 0.5 self employed, and debt to income is 40, monthly income is 80, and self employed is 1. So Z is equal to, we can put that number. So here it is, if I am getting, it is 2.46, so I can put this into minus minus plus, so exponential 2.46. Now if I solve this, then I am getting 7.9. So probability default is 7.9, which is a big number, and which means that around 8 people out of 100 are going to default, and this is also one of the important consideration for it. Now there are other types of variables also playing a role here, like banks update their probability default using behavioral signals, like for example how many they have missed the late payments, roll rates, days past due, right. So how many days they have passed. Then here we have overdraft utilization, how many sometime banks, based on their credit score, credit rating, they often provide the overdraft utilization, revolving line drawdown, that here you have. Then you have the cash flow, turnover decline, GST, sales proxy. So all these things they cover, and based on that they calculate time varying probability defaults. And nowadays, because of the better computational capabilities, you will find that majority of them are now focusing on building up the machine learning model. So how the probability default modeling is expanding. If you ask in 2026 what kind of models people are using, so now you have like logistic regression is of course a good or popular measure or appropriate measure also. Then you have the random forest large data set model, then neural network kind of model are there. Now banks are also deploying technology through the deep learning kind of setup, wherein they are trying to gather different details, work style, lifestyle, and what is the earning, all those parameters they are considering. But I wanted to the major focus why we touched upon this topic was that we wanted to touch upon some of the technical aspects. So some of you, after doing this particular course, may be interested in taking up banking sector jobs, and in banking sector jobs probability default calculation matters. So I would request all of you to please go through the logistic regression architecture, how it works, and maybe if you have some courses available in statistics on the portal of NPTEL, then you can also look at and try to go through it. You should also try to learn the implementation of this model in R, Python packages. Random forest and machine learning methods are evolving. I think these are buzzwords right now, and a lot of banks are already deploying. So if you have some people working already in the banking sector, especially in the analytics domain, not in the credit domain that we normally see. In the analytics domain, mostly located in Bangalore, Noida, or Gurugram, or Hyderabad, all those places, you'll find that they are working on large data sets. So for example, if you are working in these organizations, then you will be receiving the data from different geographies. For example, Mexico, 2.5 million customers of Barclays, and they have different debt or debt to income ratios. Based on that, they will be telling you to predict the data, and you may be using a large data handling models, and those models become important. Shrinkage based models are also quite popular, and those models are also playing important role. People are also using the non-linearities and interaction terms like sector into leverage, income into utilization. Then they are also going for the structured data called KYC, bureau, transactions and others. So, overall what appears that when we are considering the calculation of probability default, then we must know that it is an art. This particular lecture may have exposed you to those dimensions where you need to go beyond this course and try to explore. With this, I am stopping it here. Thank you. Thank you so much for your attention. I appreciate it.